You know, Louisiana's coast is a place of incredible contradiction. On one hand, it's literally disappearing, but on the other, it holds one of the planet's most powerful tools for fighting climate change. So let's dive into this and try to make sense of it all. Just look at this number for a second. 42.9 square kilometers. That's the average amount of Louisiana's coast that just vanished every single year between 1985 and 2010. It's one of the fastest rates of coastal land loss you'll find anywhere on Earth. It's staggering.
But here's the amazing part. What if the solution to saving this place was actually hidden right there in the soil? What if we could unlock a kind of buried treasure from the mud itself? That's the huge idea we're going to unpack today, and it's all about something called blue carbon.
Okay, so to really get what the opportunity is here, you first have to understand the scale of what's at stake. We're not talking about just any old coastline. This place is a global heavyweight. The scale of this is it's mind-blowing. Louisiana's wetlands are a genuine climate superpower. They punch way, way above their weight, soaking up and storing something like 6 to 8% of all the blue carbon that's captured by tidal marshes across the entire planet. This is an absolutely world-class natural asset. So you've got this fundamental conflict. On one side, you have this catastrophic land loss. And on the other, there's this incredibly ambitious plan, the Coastal Master Plan, that's all about building and saving tens of thousands of hectares of these wetlands. It's a great plan, but great plans, well, they cost a lot of money. For the last decade or so, a big chunk of that money has come from the huge settlement after the Deepwater Horizon oil spill. But here's the thing, that was a one-time payment. And as you can see from this timeline, we are heading straight for a funding cliff. By the early 2030s, that main source of cash is going to be all used up.
And the gap we're talking about is enormous. To actually get the whole Coastal Master Plan done, Louisiana is looking at a shortfall of more than $20 billion. That is a massive hole to fill. And it begs the question, where in the world are they going to find that kind of money?
And this is where we get to the blue solution. The whole idea is to take Louisiana's biggest environmental strength and turn it into a sustainable source of money to fund its own rescue. So let's just quickly define what we're talking about. Blue carbon is, pretty simply, the carbon dioxide that gets pulled out of the atmosphere and then stored for the long haul in coastal ecosystems. Basically, you can think of these wetlands as these giant, super efficient carbon sponges. And this really shows you just how powerful those sponges are. To store the same amount of carbon in the soil as just 1 hectare of Louisiana marsh, you'd need somewhere between 63 and 84 hectares of an average forest. That's an absolutely incredible level of efficiency, and it's what makes this whole ecosystem so valuable in the climate fight.
The logic here is actually beautiful and simple. In theory, you create this perfect self-funding cycle. Step 1, you restore the wetlands. Step 2, you go in and scientifically measure the extra carbon that they're now storing. Step 3, you sell that measured amount of carbon as a credit. And then the most important part, step 4, you take that money and plow it right back into more restoration projects. It's an engine designed to save the coast, paid for by the coast itself.
I mean, it sounds like a perfect plan, right? So why isn't it already happening everywhere? Well, it's because turning this really elegant idea into a certified, sellable product is a massive puzzle. Here's the first big question the carbon markets are going to ask you. If you restore marsh that, might have stored some carbon on its own, how can you actually prove that your project made an extra difference? And that right there is the core of the additionality problem. To get a carbon credit, you can't just be doing business as usual. You have to prove with science that your restoration project is locking away carbon that absolutely, positively would not have been stored otherwise. The impact has to be truly additional. And then comes the even trickier question, especially when you're talking about Louisiana. The people buying these credits, they want a guarantee. They want to know that the carbon you're storing is going to stay locked up for good. But how can you possibly make that promise in one of the most dynamic, rapidly changing landscapes on the entire planet? This is what's known as the permanence problem. The industry standard is usually a 100-year guarantee, and trying to provide that level of certainty in a place with sinking land, rising seas, and hurricanes, well, that is a huge scientific and logistical challenge. But here's the good news. These challenges aren't dead ends. They are known problems, and scientists have actually laid out a pretty clear path forward, a roadmap to the solution. A major new research paper, and it's the basis for this whole explainer, brought together experts from all over the world to basically create a checklist. They identified 20 really specific knowledge gaps that we need to fill to make Louisiana's blue carbon market a real thing.
And those 20 needs all fall into these 5 key buckets. You see, it's not just about the biology. It's also about policy. It's about developing the right rules for accounting, and about getting way more precise measurements of how carbon and other gases, like methane, are moving through this really complex system.
So here's what that scientific to-do list looks like. On the policy side, they've got to figure out who legally owns the carbon and how the funding will work. For accreditation, they need to take the global rules and adapt them to Louisiana's very unique situation. And on the science side, they need better ways to track carbon in the soil, account for methane, and even track the carbon that washes out into the ocean. It's a detailed path, but it leads to a real working market.
And this is why this whole thing matters so much, even beyond Louisiana. As the researchers themselves point out, if they can solve this incredibly hard puzzle in Louisiana, the solutions and the methods they come up with could literally become a blueprint for similar coastal wetlands all over the globe. Which, of course, leaves us with the ultimate question. The coast is sinking, the funding is running out. It really is a race against time. Can the science and the policy catch up fast enough to unlock this huge blue carbon treasure before the treasure itself is lost to the sea?